Alright, concept number 5 is writing an equation or quadratic function in vertex form. Okay, so I wrote the vertex form on top, y equals a times the quantity x minus h squared plus k. And why is this in this unit? Well, I can convert this standard form to vertex form using perfect trinomial squares. Alright, we're making a trinomial square. Or completing the square. Alright, so I'm going to go ahead and take this y equals x squared minus 18, x squared minus 12x plus 18. I'm going to write it in vertex form, and I'm going to identify the vertex. Here we go. What I'm going to do is, since this 18 is not a perfect square, I'm going to go ahead and move it on over to the other side. I don't have a trinomial square, so I'm going to make it y minus 18, okay? And then I'm just going to put plus blank equals x squared minus 12x plus blank. Alright, again, when I complete my square on this right-hand side, I have to add that portion also on the left-hand side to keep everything balanced and equal. Okay, so I'm going to take this negative 12, right? I'm going to cut it in half, and then I'm going to square it. So now I have negative 6 squared, and that is 36, and I'm going to add 36 to both sides of the equation. Now I made this trinomial square here on the left. On the right. On the left, I'm just going to go ahead and simplify. Y minus 18 plus 36 is y plus 18. 36 minus 18 is 18. On this side, take my trinomial, factor it down to x minus 6 squared. And now I'm going to just move this 18 back over here. And I get y equals the quantity of x minus 6 squared minus 18. And that is vertex form. My a term is only 1. My h should be 6. My k is negative 18. And I actually do need this vertex. It does ask for the vertex, right? And then again, that is my hk here in the vertex form. So in this case, it is 6, negative 18. Always the opposite of whatever it is in the equation, right? So if it's negative 6, h is 6. And then negative 18 would stay negative 18 for k. Okay. I'm going to go ahead and show number 10 here. So go ahead and give that one a try. Take your time, work through it. Just go step by step. I know it's a hard problem. Okay? Don't worry if you get it wrong. Just look at my answer, correct it up, see if you can figure out what you learned from your mistakes if you get it wrong. Okay, here it is. Pause if you need. Okay, oops. Here we go. Number 10. Okay, y equals the quantity of x minus 11 squared minus 105 is my vertex form quadratic function or equation. And then I have my vertex being 11, negative 105. Okay. Concept 6 is taking this and applying it into kind of a real life scenario. And I am going to do the same thing. I'm going to go ahead and make a vertex form. This time we have an a term, which is going to make this a little more challenging. Alright, here we go. Last problem here. Concept number 6. Number 11. Here we go. The height, y, in feet of a baseball t seconds after it is hit can be modeled by the function of y equals negative 16 t squared plus 96t plus 3. Find the max height of the ball, which would stem from my vertex, which is why I'm going to take it in vertex form. And then how long, it says, supposed to be say how long does the ball take to hit the ground, how many seconds, right? And that is me just solving for t, and I just plug in 0 for y, which I don't have to do in vertex form, but I'm going to do it anyway. Okay, so here we go. Y equals negative 16t squared plus 96t plus 3. Okay. What I'm going to do is move this 3 on over to the other side. I do not have a perfect trinomial square. 3 is prime. So now I have y minus 3 equals negative 16t squared plus 96t. And I need to complete the square, but the first thing before I complete the squares, I have to factor out this negative 16. I need a term to be 1. Alright, and I don't want to divide by negative 16 because that's going to be a mess over here, right? So I'm going to factor it out, and that would be my a term. So here we go. I have y minus 3. I'm going to do plus whatever I need to complete the square. I'm going to factor out negative 16 from both of these. So that leaves me with t squared minus 6t. And then I'm going to say plus blank to give me that perfect trinomial square. b divided by 2 squared, so I have negative 6 divided by 2, which is negative 3. And then squared, which is 9. So I'm going to add 9 to this side. But real quick, before I go to the other side, right, I'm actually not going to add 9. I'm going to add 9 times negative 16. And that's what I'm going to put in there. 9 times negative 16 is negative 144. And that is probably the biggest mistake people make. They just add 9 over there. But the thing is, on the right-hand side, this is a whole term. And therefore, 9 is not equivalent on this side. It's actually 9 times negative 16 to give me what's equivalent on this side. Okay. Once I have that, I'm going to keep on going. On my left-hand side, I combine like terms. Y minus 147 equals negative 16, and then I'm going to factor this trinomial square to t minus square root minus 3 squared. Alright, you can check real quick. T times negative 3 is negative 3t. Double that, negative 6t. It works. Alright, perfect. And now, just like the other problem, I'm just going to add this 147 kind of back on over to this side. And that gives me my vertex form. Y equals negative 16 times the quantity t minus 3 squared plus 147. I know it didn't really ask for it to be in vertex form, but I'm going to just box it so you guys know that is the vertex form I was looking for. Has an a term of negative 16. And now I'm going to use that to find the maximum height. The maximum height stems from my vertex, which is the hk. In this case, it would be 147. But really, 147 is the max height. So I'm going to say the max height, I spelled it wrong, is 147 feet. Okay, perfect. Alright, so now one last step is to find how long does it take for the ball to hit the ground. That's in seconds, and that's really me solving for t. So I could put 0 in my initial equation and solve for t, or I could just plug it in here, which I might as well just show you to show you. Okay, so here we go. Negative 16 times the quantity t minus 3 squared plus 147 equals 0. And really what I'm going to do is solve by taking the square root. So I'm going to subtract 147 from both sides. I get negative 16 times the quantity t minus 3 squared equals negative 147. Divide by negative 16 to isolate my t squared. So t minus 3 squared equals, and this doesn't come out equally or evenly, so it is positive 9.1875. Then I'm going to take the square root to both sides of the equation, giving me t minus 3 equals positive negative 3.03. Add 3 to both sides, and I get t equals 6.03 and negative 0.03. Okay. How many seconds? Well, 6 seconds and negative 0.03 seconds. Wait. Do we have a negative seconds? Definitely not. Therefore, my answer is this one right here. So, it takes 6.03 seconds to hit the ground. Alright, and there are our 3 answers that we were looking for. Go ahead and zoom out a little bit so you guys can take a look at that. Alright, a tough problem. Totally understand. I do believe you have 1 or 2 in your homework. You will definitely do one somewhere. I did put this on the test last year, but as an extra credit problem. So I think I may do the same here this year. Alright, that's all I got.